let's talk about for 15 minutes or so solving. We're going to continue talking about solving quadratic equations. We're still talking about that. And the first method I showed you was using the quadratic formula, right? So we were able to find our roots. Remember that if your discriminant is negative, right, there are no solutions, right? This parabola never crosses the x-axis. So this isn't completely new, but I need to show you, if I ask you to solve by using the quadratic formula, obviously you need to use this method, but you also need to be able to solve it by graphing, we call it. So remember, when you're asked to solve a quadratic, you're asked to essentially find the x-intercepts, which you also call the roots, which you also call the zeros, which are also the solutions of the quadratic, okay? So you're still doing the same thing here, right? This is still solving quadratics, okay? This is the same concept, just a different way of looking at it. You're still doing the same thing, finding the x-intercepts, right? Finding x-intercepts is possible. Note that if lines do not touch, there's no x-intercept. Okay. Two options here, and it's really going to be up to you. I prefer the second. That is my go-to, because usually the main reason why we would want to choose this method of solving is when the equations look very ugly. You don't want to be foiling or anything like that. Okay? But anyways, option one is let y equal to 0 if present, just like before. Okay, that's always going to be the case because we're essentially finding the x-intercepts, remember. Rewrite the equation in general form, right? So you want to make it look like this. Oops. Right? You want to have everything on one side and then it equal to 0. That would essentially have been your y, right? Enter the left-hand side into y1, the right-hand side into y2. Second, trace 5 to find all the x-intercepts. So you're sort of familiar. This is what we were doing. Remember, I told you to type in the equation into y1, and I told you to type in y2 is equal to 0, right? We were finding the x-intercept. So there's nothing new there. I'm going to focus on this method right here. Okay. Option 2 is let y equal to 0 if present, and there's no rearranging, right? No rewriting. Sorry, I'm going to write it. Rewriting here. No rewriting. That's the special part about second option. You don't rewrite anything. Okay, you simply enter the left-hand side into y1, the right-hand side into y2. There's no rewriting necessary, right? And then second, trace 5 to find any and all x-intercepts. Okay. Note, since you're finding x-intercepts, you must answer number 0, right? That is going to be the kicker, that you need to remember that, and you'll see in a bit why that is. Okay, so let's go with option 1 here. If you choose to go with option 1, this is how you would do it. We're on page 38, right? So rewrite. Okay. So we essentially have 32x squared minus 15x plus 50 is equal to, on the other side, we're distributing, right? That 2, it could have been a negative 2, what have you, right? You just multiply that across. So 2 times 6 is 12x squared plus 250x plus 150, right? Like that. And then we bring everything over to one side. So that'd be 32x squared minus 12x squared. I'm bringing this one over. Next is I have negative 15x. This one comes over subtracting, right? Negative 250x. And then I have the 50 that's already on the left-hand side. And I bring the 150 over subtracting, and then you have nothing left on the other side. And so when you clean that up, you get 20x squared minus 265x, right? Because negatives add. You add the negatives, so you have negative 265 minus 100 is equal to 0. Type this into y1, type this into y2, and then we go second trace, 5, right? That's intersect. And let's go ahead and find them, okay? So type that into your, we're going to turn off plot 1, remember that? For not using L1 and L2, you turn that off. You don't want it to give you any issues there. And I know that I'm expecting this to point up, to be narrow. That's going to help me. Right? Enter that. We enter y2 is equal to 0, so we're essentially finding the x-intercepts. And it's not working out for me very well, is it? So I'm going to go zoom 6. Zoom 6, get it back to the... Okay, so I'm seeing one of the legs here. So what do I expect? I expect it to open like this, right? So I'm going to have to go window, X max. I'm going to go 100. I'm going to go all out here. And my Y min, I'm going to go negative 100 as well. So X max, I'm increasing the right side of the screen, and I'm bringing down the bottom of the screen, right? So graph. Oh, there it is. So now I realize, okay, this is where this is going. It was a bit overkill to go X max 100, so I'm going to bring it down to like 50. So you're going to go to Y window, X max 50 is enough, but the Y min, I need to go probably, I don't know, negative 500. Let's try that. We're good. Do we need the vertex? Do we need to see the vertex right now? X-intercepts are fine, so let's just leave it like that. Second trace 5, the first curve. Oh, there it is. My cursor is jumping quite a bit. Do you see that? But it's closer to the one on the right. So enter, enter, enter. And so watch this. It's going to be, there you go, 13.620. And the first one is going to be second trace 5 again. Jump over to the red line. Go across like that. Enter, enter, enter. That's 0.370. Oh, I'm forgetting the negative, right? It's a negative. It's a negative 0.37. And now the second way of doing things. So cut it right here. Option 2. Is let's rewrite the original thing, please, just for just this once. I'm just copying the original here. Hope you can see that. And so all you're going to show me when you do this on a test or AC, you're just going to take right under this, you're going to say, hey, I'm going to put this into Y1 and type this whole thing into Y2, and then I'm going to go second trace. And now you know why I prefer that method, right? It saves you from having to do all this algebra to get there. There's one caveat, there's one problem that I'm going to show you now. So I'm going to clear whatever is in Y1 and Y2. and I'm going to enter it exactly the way it is. 32x squared minus 15x plus 50. y2, I'm going to go 2, and then I'm going to have to use the brackets. 6x squared plus 125x plus 75, close brackets. That's exactly the way it is there. And now we're going to graph this. Wait a minute, what's happening here? We have two, right? We have two quadratics, and they're going to somehow meet each other. They're going to cross each other. So we're going to go zoom 6 here to reset my window. Zoom 6. There's the red, and the blue is nowhere to be seen, right? But I know they're both pointing up, so I'm going to start zooming out a little bit. So go window. I'm going to go negative 50, positive 50 for the x min and x max. Then I'm going to go negative 50, positive 50 for my y min, y max. So I'm increasing everything on my window, all four sides. I'm going to hit graph. There's the red one. Did I not? What happened to the blue one? I'm looking at the y-intercept is like way 2 times 75, that's 150, right? So let's increase our window even more. I'm going to just go the y min or y max, right? So I'm going to go negative 200 with the y min and 200 positive with the y max. Let's try that. Oh, there it is. So you need to focus in on this part right here where they cross. Okay, that's where you want to focus in on. Not so much the rest. So because the points where they intersect, that's what we're interested in. So I'm going to go second, trace 5. Right? Now, the first curve is the blue one, right? You're on the blue. So just go as close as possible to that first point where they cross and hit enter 3 times. Do you notice that point? The x value at least? Negative 0.37 and 59.82. We're going to write that down for now. But you can't, this has to be turned into 0. So it's actually negative 0.370, right? So you gotta omit, you gotta make sure you don't write the y value in because that'd be wrong, right? You're just interested in the x values. Let's go ahead and find the other one. Let's try something. I don't play around with the zoom too much. Let's try a zoom here. I think zoom fit. You see that one there, zoom fit? Let's try to see if that works for us. Oh, that did a pretty good job, didn't it? So it was able to fit both curves. And now I'm going to go zoom, and I'm going to use the zoom in function, zoom in feature. So you got to go in to this area here. That's the one I'm interested in right there. And now I see that they cross there as well. So I can go second, trace 5, enter, enter, enter. And that's the other point. 13.62, 5,779.43. But you don't want the y value, right? So you turn that into 0. So it's really 13.620. Okay. I will put a note here. Note, use zoom fit, right? Or zoom in, right? To help you, right? To help. Most of the time, they're not as crazy as this. I promise you. Most of the time, they're not. I just picked a really, really crazy example, right, for you to see. I want you to try for tomorrow, right? I want you to be able to do this, but I also want you to refresh quadratic formula. So I'm going to ask you to do this. If you go to page 39, and for some reason, the other questions went all the way to the back cover. I don't know why. So right, page 40 shows up at the back there. I don't know what happened. So I want you to try pages 39 to 41. Right? Solve by graphing and using the quadratic formula. Okay? You don't have to do them all if you don't have time, but pick at least a few, right? 2 or 3 to see, can I do this? Am I able to do this? Because your answers should match, right? Your x-intercepts using the quadratic formula or the solving method should match.